Talampric is just, I just put it over there. There's nothing to do with the quadrant. Talampric asked, can you explain why XY plane the bottom quadrant instead of the top quadrant? I just put it there because of space. Okay, Talampric, there's nothing to do with first quadrant, second quadrant, third quadrant, okay? So you can see that now. Another important thing that I want you all to remember, okay? Okay, watch this, okay? Watch this carefully. On the element, okay? On the element, point X to point Y, how many degrees is this? Anyone? 90 degrees. Okay. On the element, point X to point Y is how many degrees? 180 degrees. Okay. So what does this mean? If on the element it is theta, on Mohr circle is what? 2 theta. Are we clear? Okay, you can see that, right? I mean, there is an equation. If you want me to prove this mathematically, I'll be writing 1.5 pages of equation, and then you see this. I don't want to waste your time. Okay, so you can see what you can see now is an important thing that you have to know. Okay, so on the element, is theta, on Mohr circle is 2 theta. Okay, very, very important. Okay. So we learned quite a few things now, right? Okay. Then there's another point that I want to highlight. Okay. Is I'm going to call this point over here also known as our stress 1, and this point over here is also known as our stress 2. Okay, I'm going to call them stress 1, stress 2. You can flip over, it's fine. Does not matter. As I said again, if you want to call here stress 1, you want to call here stress 2, it's okay. We are a free country. Yes? We are not communists, I think. Even China is not communist. Look at how liberal they are. They are capitalists, right? Look at the amount of money they're making, okay? So what you can see down here is stress 1 and 2 are known as principal stress. Okay, they are known as principal stresses. Principal stresses means the shear stress is equal to what? 0. Right? You can see stress 1, stress 2, right? The shear stress are equal to what? 0. Okay. Okay, so that is enough of, I think, normal stress. I think you guys should be, you can relate the normal stress to Mohr circle now, okay? Yes. Say it again. It's the element rotation. Wait, not chat. It's just normal stress. Now just remember. Okay. Okay. Next, we are going to look at shearing stress now. That's where it matters. Okay. So we are going to look at shearing stress or shear stress. All right. But before I go on into shear stress, if we look at the normal stress, right? If we look at the normal stress, we know that the normal stress, the formula is equal to Px over A, or I don't call direction, okay? It's P over A plus or minus stress Y over I Y Y Z plus minus of stress Z over I Z Z Y. If I call, okay, if that's the case, I'm going to call it X then, okay? So we know that's the formula that we always calculate, yes or no? Axial loading, bending moment in the two axes. Okay? And then if we look at the shear, all right, we look at the shear, I'll let you guys finish copying for a second. And then if we were to go into the shear, there's also one formula. And you all know how to calculate the magnitude, right? So I write down the formula for the shear is equal to TR over J plus or minus Vy over IZZ QZ divided by T plus or minus VZ over IYY QY over T. That is how you determine the normal stresses and the what? Shear stresses. That's why this topic seems to be complicated, is because we integrate everything together, including the kitchen sink. Okay? That's where graduates from here have to be able to analyze this. Okay? We can do another online exam. You can post that question on chat to see anyone come back to see can they formulate the answer. I will tell you no. Okay? Why? Because now we integrate how many topics? Whatever we learned in week 1 to now, all we combine what? Together. Okay? That's why if you check the stock market, check the stocks just went down the toilet bowl. Do you realize that? You play stocks? No? Okay. Just type chat and you see their stock market rate. It's so bad now. Hey? What? Oh yeah. Oh yeah. That's very good. Okay. Focus. Okay. Don't get distracted. Okay. Now let's look at shearing stress. Okay. So shearing stress, we have positive shear and negative shear. Okay. So let me write down positive shear first. Okay. So I'm going to use this diagram. Okay. So positive shear looks like this. Okay. And then I'm going to draw below. I'm going to get rid of this. And the one below is negative shear. And negative shear looks like this. Okay. And you can see the difference, right? So the difference, what is, later on I'll tell you why is this positive and why is it, but I want you to look at the deformation pattern. Okay. Now, if we were to stretch the both ends, okay, if we were to stretch, I'm going to highlight in pink. If we're going to stretch these 2 points, right? It looks like this. Okay, it looks like this. So this is the deformation pattern. Okay, so the one in pink is known as the what? Deformation pattern. Okay, and then again, if I stretch the other, if I were to do the negative shear, it will look this way. Okay, so the deformation is different. Now I'll write this statement over here. Okay, both there is no both negative and positive shear are either as good or as what? As bad. Okay. It does not mean that you have positive shear, you have more money, negative shear, you have less money. Both are as good or both are as bad. Bad is for concrete. Okay. Ceramics or concrete cannot take shear. Ductile material, shear is okay. Okay. So there is no like good shear or bad shear. You cannot say positive shear is a good shear, negative shear is a bad shear. Both are as good, both are as bad. Unlike normal stress in compression is usually a good thing. Normal stress in tensile is not always a good thing. Yeah, can you see that? Okay. Now, let's relate the shear to Mohr circle now. Okay. So I'm going to call this X again. This will be our what? Y. Okay. That's our X and that's our Y. So you can see over here, stress X is equal to stress Y is equal to 0. Shear XY is equal to shear YX and it's not equal to what? Or is equal to positive. Okay, because we call it what? Positive shear. Okay. So now we relate this into Mohr circle. Okay. Normal stress, shear stress, okay. Shear stress, element rotate clockwise, right? Element rotate anti-clockwise. Okay, so for now, we know from our normal shear, our stress X and stress Y are on the 0 line, right? Are on a 0 line. Okay, those in class, I don't want you all to write anything now. I want you all to just listen. Those online, the same, okay? We are going to deal with point X first, okay? And we're going to focus on this arrow over here that I highlight in what? In yellow, okay? And then I want you to put your finger on the center of the element. Okay, you put your finger over there. Okay, you put your finger over there. Okay. Focus on the highlighted yellow arrow. How will the element rotate? Clockwise or anti-clockwise? Anti-clockwise. Very good. anti-clockwise. Right? So now, question for you, anti-clockwise, is it on top or below of the Mohr circle? Below.